Hello students, welcome back to my channel. I am again here with a new video in continuation with the other videos. Okay, we are discussing questions from 2022 Neet exam. Right. So coming to question 20, the angle between electric lines of force and the equipotential surface. Now students, you see, suppose just say let us take you have a metal surface. Okay. Now we all know that there is no electric field here. And suppose you have some charges here. So lines of force should start exactly on the surface. You will find that lines of force are there because of these charges. But but because at just inside there is no electric field. Just there is no electric field. So that means here you will find it will be an equipotential surface because a metal surface is always an equipotential surface. Okay. So it is just like this. Suppose you imagine some heat is provided to a metal. What will happen? The heat will evenly be distributed throughout the metal and the metal will attain the same temperature throughout. Why? Because of the high conductivity of metal. Okay. Similarly, inside the metal surface, there is no electric field intensity. So charges will get distributed so that the potential remains same. So this is an equipotential line. As you can see, electric field lines are always at right angles to equipotential line or plane. So correct option is 90 degree. Then coming to question 21, two hollow conducting spheres of radius this much and this have equal charges, potential would be. Now students, very simple question. We all know that potential on a charged sphere. Okay, if Q is the charge and R is the radius, then potential is given by KQ by R. So you can see V varies inversely as R. So the smaller the radius, more will be the potential. Smaller the radius, more will be the potential. So the potential would be more on the smaller sphere. Then moving on to the next question, question 22. As the temperature increases, the electrical resistance. Now we all know that for conductors, the coefficient of resistivity is positive. In other words, resistivity as well as resistance increases with an increase in temperature. Whereas for semiconductors and insulators, it is just the opposite. That is, the coefficient of resistivity is thermal coefficient of resistivity is negative. In other words, the resistance decreases with an increase in temperature. So the correct option is increases for conductors but decreases for semiconductors. First option will be the correct option. Okay. What happened? It's not writing. Yeah. Then moving on to the next question. A copper wire of length 10 meter and radius this much has electrical resistance of 10 ohm. The current density in the wire for an electric field strength of this. Now what is the basic formula for current density? Okay, so current density is given by basic formula of current density is current per unit area. Since the radius of the copper wire is given, we can always have I upon pi r square. But we don't know current. So in order to know the current, we can use Ohm's law. Ohm's law can be written as voltage upon resistance. Voltage upon resistance. So how to calculate voltage? Electric field strength is given and length is given. We all know that electric field is the negative potential gradient. I have omitted the minus sign because here it is of no use. Electric field strength is the negative potential gradient. So accordingly, potential difference can always be written as E into L. So rewriting this, V as EL, we have EL upon R into pi R square. Just it's a matter of substituting the values. Electric field strength is given as 10. We'll be substituting all the values in SI unit. Okay. Now length is given as 10 meters upon resistance is given as 10 ohm, and this will be pi into radius square. So when you square it, 10 power minus 2 becomes 10 power minus 4 and root pi becomes pi. So pi gets cancelled here. 110 gets cancelled here. 10 power minus 4 goes up, becomes 10 power plus 4. So 4 plus 1 is 5. So 10 power 5 SI unit. SI unit is ampere per meter square. So we have second option. Then moving on to the next question. Question number 24. Two resistors of resistance 200 and 200 ohm are connected in parallel in an electrical circuit. The ratio of the thermal energy developed in this. Now you all know that if you have a resistor connected across a, let us say, voltage V naught, then the power developed is given by V naught square by R, electrical power developed. So here by thermal energy we mean thermal energy per unit time, and that per unit time can be taken as thermal energy per unit time can be taken as power. So we are basically, we want the ratio of the powers developed. So as you can see, since they are connected in parallel, so in parallel V remains constant because all of them are at the same potential. So accordingly I can write P varies inversely as R. In other words, power generated in the 100 ohm resistance upon power generated in the 200 ohm resistance is equal to 200 by 100 inverse. So fourth option is the correct option. Then moving on to the next question, you can see 2 point charges plus minus q and plus q are placed at a distance of L as shown in the figure. The magnitude of electric field strength intensity at a far off distance. You can see R is too large compared to L, where L is the length of the electric dipole. Remember students, this is an electric dipole. So at a far off distance from an electric dipole, we all know that the electric field strength is given by K into P upon R cube into under root 1 plus 3 cos square theta, where this angle is theta. This is the direction of dipole moment from negative to positive charge, and this angle is theta. So this is the formula. So from here you can see that E varies inversely as R cube, small r, capital R I have to take. So fourth option is the correct option. E varies inversely as the cube of the distance of the point from the center of the dipole. Then moving on to the next question. A capacitor of capacitance this much is charged fully. Is charged fully by 100 volt battery B as shown in the figure. Then it is disconnected from the battery and connected to another uncharged capacitor of capacitance C equal to 900 picofarad as shown in the figure. The electrostatic energy stored in the system will be. Now student, this is a factual based question. Even though I'll derive everything, but I would advise you to memorize these things so that you save time in the exam hall. Okay, now you see, initially the energy, electrostatic energy in this capacitor, initial electrostatic energy in this capacitor is half C V naught square, where 100 volt I have taken as V naught. This is the initial energy, we all know. Now once it is connected with an identical capacitor, what happens? The charge is equally distributed amongst the two because both are identical capacitors. So charge will be equally distributed between them, and accordingly potential will also reduce to half because Q is equal to CV. So if Q gets reduced to half, V will also get reduced to half. So now in other words, the potential difference across each is now V naught by 2. V naught by 2. So the final potential energy will be twice of potential energy of any one of them. So for any one of them it is half C V naught by 2 whole square, V naught by 2 whole square. So this is basically C V naught square by 4. Okay, so this is the energy stored. So that means half the energy is remains and the rest half is lost in the form of heat energy mostly, but partially it could be in the even in the form of light energy as well as sound energy. But mostly it is the loss is mostly in the form of heat energy. So out of the total energy of the capacitor, initial energy of the capacitor, only half remains stored. So if we can find the initial potential energy, just divide by 2 and get the answer. So let us see what is the initial potential energy. Let us see what is the initial potential energy. Half C is 900 pico. Pico means 10 power minus 12 into V square. V is 100. 100 square is 10 power 4. So this will be 4.5 into 10 to the power minus 6, because 2 zeros from here and 4 zeros from here, 10 power plus 6, and this is 10 power minus 12. So the new energy stored in the system means both the capacitors together, the final energy is half of initial energy. So half of 4.5 is how much? Half of 4.5 is 2.25 into 10 power minus 6. So first option is the correct option. Moving on to the next question. A Wheatstone bridge is used to determine the value of unknown resistance X by adjusting the variable resistance Y as shown in the for the most precise measurement of X. Now student, this is something which is mathematically proved in the degree level. Okay. So for most precise measurement, that is in order to have highest degree of accuracy as well as to maintain high sensitivity of the instrument, all the four resistors should be approximately same. That is a first and foremost requirement. Okay, only then the error will be reduced so that the precision will increase. And if they are small, the change in resistance due to temperature fluctuation will be less, because what happens during the course of experiment conduction, the temperature of the laboratory might increase or decrease, so thereby affecting the resistance. If it is small resistance, then the heat produced will be less, so that there practically there won't be any change in the resistance. So fourth option is the correct option. Okay, we'll stop here students. That's all. Thank you.